Good morning, this is Kasturi Day. I was continuing with the chapter Elements, Compounds and Mixtures according to ICSE syllabus class 7. So I'll continue with the names and the symbols of some elements derived from their English names. For example, hydrogen represented by capital H, nitrogen capital N, oxygen capital O, carbon capital C, sulfur capital S, phosphorus capital P, boron capital B, chlorine capital C small l, fluorine capital F, bromine capital B small r, iodine capital I, arsenic capital A small s, platinum capital P small t, germanium capital G small e, helium capital H small e, neon capital N small e, argon capital A small r, krypton capital K small r, radon capital R small n, xenon capital X small e, chromium capital C small r, cobalt capital C small o, radium capital R small a, manganese capital M small n, nickel capital N small I, barium capital B small a, uranium capital U, silicon capital S small I. Now the names and the symbols of certain elements which are derived from the Latin and Greek languages. For example, sodium known as natrium, so symbol is Na. Then potassium is known as kalium, capital K. Then magnesium, magnesia, symbol is capital M, small g. Aluminium, alumen, capital A, small l. Calcium, calx, capital C, small a. Iron, ferrum, capital F, small e. Copper, cuprum, capital C, small u. Zinc, zinke, capital Z, small n. Then silver, argentum, capital A, small g. Gold, capital A, small u. Aurum, it is known as, mercury is known as hydragyrum, capital H, small g. Lead, plumbum, it is known as plumbum, capital P, small b. Tin, stannum, capital S, small n. Antimony, it is known as stibium, it is represented as S, small I. That is the symbol of antimony. Then the molecules of an element. The molecules of an element can exist freely. Okay. The molecules of an element can exist freely. They are represented by a formula which indicates how many atoms of the element have combined to form it. Okay. So one molecule of an element represents how many atoms are there. For example, in molecule of hydrogen is H2. That means 2 atoms of hydrogen are present in one molecule of hydrogen. Then nitrogen also N2. So 2 atoms of nitrogen present in one molecule of nitrogen. Oxygen O2, again 2 atoms. Then fluorine F2, 2 atoms. Chlorine 2 atoms, Cl2. So the number of atoms which are present in one molecule is known as the atomicity of that molecule. So what is atomicity? Atomicity of a molecule is the number of present in one molecule of an element. So then example, molecules of hydrogen has 2 atoms, so it's diatomic. Oxygen 2 atoms, diatomic. Nitrogen 2 atoms, diatomic. F2, that is fluorine, 2 atoms, diatomic. Chlorine 2 atoms, diatomic. Ozone O3, so it's triatomic. Phosphorus P4, that is tetraatomic. Sulfur S8, so octatomic. Helium He, that's 1. Then neon Ne, that's 1. Argon Ar1. Krypton Kr1. Then xenon Xe1. Radon Rn, that is 1. These are all monoatomic molecules. Then compound. A compound can be defined as a substance which can be split into simpler substance only by a chemical means. It's a pure substance. Why? Because they are formed by a chemical combination of 2 or more elements in a fixed ratio by mass. So they are formed by a chemical combination. When they are chemically combined, when two or more elements are chemically combined in a fixed ratio by mass, they form a compound. Okay, so they can be broken down only by chemical means into simpler substances. For example, a mixture of hydrogen and oxygen, when they are kindled, they form water. Then carbon or sulfur, when they are burnt in oxygen, they form carbon dioxide or sulfur dioxide respectively. Then common salt, which we eat in the food, we take with food. So that is known as sodium chloride. It's known as chemically, it's known as sodium chloride, and therefore they can be chemically broken down into sodium and chlorine. Now compound is represented by a formula. So what is a formula? Formula is a symbol type of thing. It's a it's a representation which indicates how many atoms of which element have combined to form a one molecule of that compound. Okay, so how many atoms of which element are there which have combined to form one molecule of the compound. For example, water, which has the elements hydrogen and oxygen, to form one molecule, it forms H2O, two atoms of hydrogen and one atom of oxygen. Then sodium chloride, common salt, sodium and chlorine elements are there. Formula is NaCl. Then magnesium oxide, magnesium and oxygen. So formula is MgO. One atom of magnesium and one atom of oxygen has combined to form a one molecule of the compound, magnesium oxide. Calcium oxide, known as quicklime. So calcium and oxygen is there. So it is represented by CaO. Sodium carbonate, that is washing soda. It has sodium, carbon and oxygen, and it is represented by Na2CO3. Then sodium bicarbonate, sodium, hydrogen, carbon and oxygen. It is represented by NaHCO3. Again, carbon dioxide, carbon and oxygen is there, so represented by CO2. Then hydrated calcium sulfate, known as plaster of Paris chemically. So it is known, the common name is plaster of Paris. Then that is elements present in this is calcium, sulfur, hydrogen and oxygen. So it is represented by CaSO4 dot half H2O. As it is hydrated, so water is present. Then cane sugar. It has carbon, hydrogen and oxygen, represented by C12H22O11. Then silica, or sand we call it. So it has silicon and oxygen, represented by SiO2. Glucose has carbon, hydrogen and oxygen, represented by C6H12O6. Sodium sulfate, sodium, sulfur and oxygen present. It is represented by Na2SO4. Carbon monoxide, carbon and oxygen, CO. Sulfur dioxide, sulfur and oxygen, sulfur SO2. Then sulfur trioxide, again sulfur and oxygen, but SO3, as it is trioxide. So calcium chloride, calcium and chlorine, and represented by CaCl2. Whereas zinc chloride, zinc and chlorine, ZnCl2. Then hydrogen chloride or hydrochloric acid. So that is represented by HCl present. What are the elements present? Hydrogen and chlorine. Then sulfuric acid. It has hydrogen and sulfur and oxygen. It is known as sulfuric acid or hydrogen sulfate. It is represented by H2SO4. Then hydrogen nitrate or nitric acid. Hydrogen, nitrogen and oxygen. HNO3 is the formula. Then sodium hydrogen carbonate or baking soda. Then it contains sodium, hydrogen, carbon and oxygen, represented by NaHCO3. Now the characteristics of a compound. What are the characteristics? They can be split into its constituent elements only by chemical means and not by any physical means like filtration, sublimation, distillation, etc. So, for example, water can be split into hydrogen and oxygen only by chemical means. Then elements combine in a fixed proportion of their atoms to form a compound. For example, hydrogen plus oxygen gives us water. So atomic ratio is 2:1. 2 atoms of hydrogen, 1 atom of oxygen. So fixed proportion of their atoms. So atomic ratio is 2:1. Again, carbon and oxygen forms carbon dioxide. Here carbon atomic ratio is 1:2. 1 atoms of carbon and 2 atoms of oxygen. So it is represented by carbon dioxide. Then elements combine in a fixed proportion by mass, forming a compound. Hydrogen plus oxygen forms water. 1 grams of hydrogen and oxygen is 8 grams. Mass is 1:8. Mass ratio is 1:8. Water is 9 grams. Carbon plus oxygen gives us carbon dioxide. 3:8 mass ratio. 3 grams of carbon and oxygen is 8 grams. Gives us 11 grams of carbon dioxide. So as matter can neither be created nor destroyed. Okay. The mass of the compound formed must be the same sum of the masses of the constituent elements. So the mass of that is formed, that is 11 grams, that should be equal to the constituent elements, carbon and oxygen, the mass of these constituent elements, the summation of the mass of these two elements, the constituent elements. Okay, so the mass of the constituent elements are carbon 3, oxygen 8. So combining together becomes 11 grams, and that is equal to the formation of carbon dioxide, which is also 11 grams. Okay, so the properties of the compound are entirely different from those of the constituent elements. For example, hydrogen is a gas and can be burned. Oxygen is a gas, can support burning. But water that is formed by combination of hydrogen and oxygen chemically forms water, which is a liquid which extinguishes fire. So this property of water is completely different from its constituent elements properties. Okay. Then carbon and oxygen. Again, carbon is a solid and can be burned. Oxygen is a gas supporter of burning. But carbon dioxide is a gas which extinguishes fire. Again, this carbon dioxide is a gas which is a non-supporter of burning. It extinguishes fire. So that property is different from the properties of its constituent elements. Okay. Now, energy is either absorbed or liberated during the formation of carbon. Carbon and oxygen, when burned, forms carbon dioxide, which is an exothermic reaction. So, energy is either absorbed or liberated during the formation of compound. Again, when copper 2 carbonate, that is green color, okay, when there is a green color compound, when it is heated, it gives out its it changes its color. It forms copper 2 oxide, which is black in color, and carbon dioxide is liberated, and that is an endothermic reaction because it absorbs heat to become copper oxide and carbon dioxide. So, energy is either absorbed or liberated during the formation of a compound. A compound is represented by a definite chemical formula. We know that a compound is represented by a formula. So, compound is represented by definite chemical formula like water. The formula is H2O, carbon dioxide, CO2 and others. Okay. So, I stop here. Please go through the videos. If you have any doubt, please write in the comment box, and if you like the video, press the like button, and if you are a new viewer to my channel or if you have not subscribed yet, please do subscribe so that you can get the notification of my next video. In the next video, I'll continue with the mixtures. Thank you.